Hello viewers. So in this video, we'll be looking at how to evaluate inverse trigonometric functions. So to do this, we're going to be following three procedures or three steps. The step number one is to determine the quadrants. For example, if you have y is equals to trig inverse, we can use the chart, but let me just explain what the chart is talking about. Now, let's look at inverse. We're going to focus on three functions: sine inverse, cosine function, cosine inverse, and tan inverse, right? So let's say we have a function. Remember, every function has a domain and it has a range. So let's assume that our function, let's call it y, is sine inverse of x, right? Now, it means that this x must come from the domain. So this will be the domain and this will be the range. But we know this is sine inverse. So what is the domain of sine inverse? Is from -1 to 1. So if x is coming from -1 to 1, remember y is the output. So it means y will be in the range. But what is the range? The range is nothing but from -π/2 to π/2. So you check the video before this one, we explained it, because the range of sine inverse, right, is going to be the domain of sine inverse. And remember, what is is going to be the domain of sine x. But what is the domain of sine x? Is -π/2 to π/2, the restriction we did in the earlier video. So it means that what? Anytime we have this one. So let's look at our quadrants. Let's say this is 0, this is π/2, this is pi, right? And here, instead of having 3π/2, here we said -π/2, which is like you're coming clockwise, right? Remember, if you come clockwise, you have negative. If you go anti-clockwise, you have positive, right? Okay, so if you look at this, what does this tell us? It tells us that this sine inverse, anytime you look for sine inverse of what? Of x, it's either you are between what? -π/2 and π/2. It means you are somewhere here, because this is -π/2 and this is π/2. So it means that sine inverse, you can find sine inverse either in this quadrant or in the what? Or in this quadrant for any x. So it means for any value of x in the domain, your y is going to be between -π/2 and π/2, which is just either this or this. So it will be either in the first or in the what? In the fourth quadrant. And that is why you see here in this chart, we have sine inverse. Sine inverse could be in the first quadrant. It could also be in the fourth quadrant. And this is the reason, because of the range, right? Okay. Then, now let's take another function. So this means that what? This tells us the sine inverse is either in the sine inverse is going to be either in the first or in the what? In the fourth quadrant. Okay. Now, the same way, let's take another inverse function, which is cosine inverse. So if we take cosine inverse of x, remember x will come from the domain and it will go to the range. But what is the domain of cosine inverse? Is still -1 to 1. So y is going to be in where? The range, which is 0 to pi, right? But what is 0 to pi? If you look at this, 0 to pi this is 0, this is what? π/2, and this is pi. 0 to pi means this way. So it means it's either in the first or in the what? or in the second quadrant. So it means that if you deal with cosine inverse could be in the what? It's going to be in the first or in the what? Or in the second quadrant. And here, so here we should include cosine inverse also here. Cosine inverse could also be in this quadrant. Okay. Always. Now, finally is what? Tan inverse of x. Where can we find tan inverse of x? The same story. This is tan inverse. So tan inverse y is tan inverse of x. And this is what is the domain and the range? The domain for tan inverse is what? Remember, we restrict it to minus pi over 2 to pi over 2. But what is the range? The range is the whole of R. No, sorry. This is the domain here. And this is the range. So what is the domain of tan inverse of x? Now remember the domain for tan inverse of x is going to be the what? Is going to be the range, right? Of tan x. Yeah, so here is going to be from minus infinity to infinity, because we're talking about x coming from the domain. The domain of tan inverse is what? Is minus infinity to infinity. But the range is now going to be minus pi over 2 to pi over 2, which is the domain of tan x. And what is this? This implies that what? Tan inverse of x is going to be either in the first or in the what? Or in the fourth quadrant. Because if you look at it, this is 0, this is pi over 2, the same thing we explained earlier. This is minus 2. So between minus pi over 2 to pi over 2, it means you are here, somewhere around here. So it's either in the fourth or in the what? Or in the first. And that is why you see that in the graph here, in this chart, you see in this chart we have tan inverse is either in the fourth or in the what? Or in the first. So it means in the first quadrant, you can have all of the three. But in the second quadrant, only cosine inverse you will get in the cosine. So cosine inverse could be in the second quadrant. But in the third quadrant, we don't have anything. It's just empty. We're supposed to have like something like cotan over there, but we are not dealing with, we are focusing our attention on just these three: cosine inverse, sine inverse, and what? And tan inverse. All right. Now, and also another thing we have here is we have something we call like a reference angle, which we did before. Look at here, we said y is pi minus what? Pi star. So what is pi star? Look at here, he said pi star is a famous angle in what? In the first quadrant. And when we take an example, I will explain how to find this y stars. And also if you are in the first, just like we did in reference angles, how to find reference angle, if you are in the first quadrant, it's still the same thing as your angle, right? So we have y is equals to y star. But in the fourth quadrant, we will have y is what? Minus y star, which is like the reference angle in the fourth quadrant. Remember, in the fourth quadrant, we used to use 2 pi minus what? Minus theta, right? But here we cannot use 2 pi because of the range of our functions. Yes. Yes. All right, so now let's go straight into exercises using this chart. Now we talked about finding the sine inverse. Let's talk about finding the sine inverse of specific values now. So we want to find sine inverse of 1. It means we're looking for an angle such that when we take the sine of that angle, it's equals to 1. Clearly, it's going to be 90, right? Because, so what we are saying is, we said let's y, we can let y to be let y to be so here the way we can write is, let's assume that y is equals to sine inverse of 1, right? Now we already said that what, because of the range of sine inverse can be found only in the first or in the what, in the fourth quadrant. This is simply because of the range of sine inverse, which is from minus pi over 2 to pi over 2. So what we can do here is we can take sine of both sides. So it means that sine y is equals to 1, right? This is just by the cancellation property, right? Because I can say, I can take sine of both sides. So sine y is going to be sine of sine inverse of 1, yes? But I know sine of sine inverse will cancel because 1 is in the domain of sine inverse. So this will just be sine y is equals to 1, right? So with this, now we can say that, what can I say here? Look at this, sine 1 is in which quadrant? Sine is positive only in the first or in the second quadrant. So now we will take the quadrant that is common. What is common? Is quadrant number 1. So it means we are in quadrant number 1, right? So then we will look for what we call the y star. Y star is always in the y quadrant, in the first quadrant. Just like here, look at here, this is where we are now. It says start with the known famous angle y star in the quadrant 1, right? So in this quadrant 1, so just think of an angle in the first quadrant which sine is going to be 90, which sine is 1. So I mean, think of an angle in the first quadrant which sine is 1. So that angle is going to be 90, which is pi over 2. But here already we said we are in first quadrant. So let me just remind us of the chart again. How does the chart look like? It looks like this. This is pi and this is 0, right? And so if you are in the first quadrant, we said y is going to be y star. In the second quadrant, y is pi minus y star. And in the fourth quadrant, we said y is what? Minus y star. So this is the chart we're using. So, but here, since we're in the first quadrant, this quadrant, it means y is y star. So it means our y is just going to be y star. But what is y star? Which is pi over 2. So it means y is pi over 2, right? But don't forget, but what is y? Look at y. We said y is sine inverse of 1. So it means that sine inverse of 1 is equals to pi over 2. All right. Now, look at this next one, b. Look at b. We will do the same thing. We will take y to be sine inverse of what? Half. Sine inverse can only be in the first or in the what? In the fourth quadrant. So the same way, it means that sine y is going to be what? 1 over 2, right? But sine is positive. It means this is either in which quadrant? Sine can be positive only in the first and in the second quadrant again. So this is similar to what we just did. So now what is common? You see that the first quadrant is common, right? So since the first quadrant is common, then we can find what is y star. Y star will be an angle in the first. Y star is always in the first quadrant. So it's an angle in the first quadrant whose sine is going to be what? Half. 1 over 2, and that is pi over 6, right? Because of which is sine 30. Now, since we are in the first quadrant, it means that what? Y is going to be y star. And this means that what? Sine inverse of what? Of half is going to be the same as pi over 6. All right. Now, how do you check whether your solution is correct? Look at what we're seeing. This is checking now. If you want to check. So to check this, what we can do, it's simply, we just need to what? We just need to take the values of sine and to see if we will get back to 1 over 2. So what I mean is by checking is this one. If you take the sine of both sides, so if you take the sine of this, let's take sine of pi over 6, is it going to give us 1 over 2? Yes, because sine pi over 6 is the same thing as sine 30, which is what? Which is half. So it means the solution is correct. So this is how to check. All you need to do, take the sine of the angle here and see if it gives you back what you have inside the domain, or what you have from the domain of sine inverse. Okay, now the next one is this one. Here, we let y to be sine inverse of what's? Of minus half. So sine inverse, again, can only be in the first or in the fourth quadrant. But now if you take sine of both sides, you have sine y is equals to what? Minus half. But sine is negative either in the third or in the what? In the fourth quadrant. So if you look at this, you will see that the quadrant that is common is what? Is this, the fourth quadrant. So this is the third quadrant. This is the third quadrant, and this is the fourth quadrant. Here we have the first and also the what? The fourth. So what is common now is the fourth quadrant. Yep. Okay. Now, we know we're in the fourth quadrant, but what can we do? We first of all need to find what is y star. Now, how do you get this y star? Y star is an angle in the first quadrant whose sine is just what? 1 over 2. You don't need to bother about the negative. The negative has been taken care of. It's just to identify the quadrant where sine is negative. So it means our y star is going to be what? Still pi over 6. Because sine pi over 6 is what? Is 1 over 2. So in calculating y star, if you have negative, don't bother about the negative. Just use the positive angle, the positive value. But since we are in the fourth quadrant, since we are in the fourth quadrant, what can we do in quadrant 4? You can say in quad 4, we know that y is going to be minus y star, right? And that is coming from where? It's coming from this chart. It's coming from this chart. If you're in the fourth quadrant, y is minus y star, which is like the reference angle. So it simply means that what? Y is going to be minus pi over 6. And what is y? Remember, our y is sine inverse of minus half equals to minus pi over 6. Okay. All right, now let's discuss for example 2. Example 2 is mainly for cosine, yes? So here, what do we do? The same procedure. Remember, this is cosine now, and we know that cosine inverse is what? Cosine inverse is either in the first or in the what? In the second quadrant, yes? Simply because of what? You know, the range is from 0 to pi. So it's going to be just from either the first or in the second quadrant. So we can let y be what? Cosine inverse of what? Root 3 over 2. Now, what does this mean actually? This means that if you take this root, you see this root 3 over 2 is from the domain of cosine inverse. So the output is going to be in what? In the range, which is 0 to pi. So which means it's either in the first or in the what? In the second quadrant. Okay. Now, if you take cosine of both sides, so you have cosine y is what? Is just root 3 over 2. But cosine is positive in which quadrant? In the first or in the fourth quadrant. So now we are going to go for the common. What is the common? The common is what? Is the first, right? In the first quadrant. Now we need to find what is y star. So our y star is just going to be what? What is y star? It's going to be an angle in the first quadrant whose cosine is root 3 over 2. And that's root 3 over 2. You can get it from cosine of what? Cosine of 30, which is pi over what? Pi over 6. But because we are in the first quadrant, right? Remember in the first quadrant, what do we say in the first quadrant? Y is going to be y star. This is always in what? In quadrant 1. So it means that y is going to be pi over 6. But what is y? Is cosine inverse of what? Root 3 over 2 is equals to pi over 6. Okay. Now, as you can see, if you take cosine pi over 6, we're going to get what? We're going to get cosine pi over 6 is the same thing as cosine 30, which is root 3 over 2. So this makes sense. Now, B, we let y be what? Cosine inverse of what? Minus 1. So this is going to be where? It's going to be either in the first or in the second. This is where you can find cosine, because this is similar to all I've explained. What this is mean is this. Look, it means you have domain. What is the domain? Cosine inverse and range, yes? This is minus 1. So the domain of cosine is minus 1. And you have your function, y is cosine inverse of what? Of minus 1. So you can see minus 1 is coming from this domain, which makes sense. But the output will be in the what? In the range. But what is the range? Is 0 to pi, right? So since it's from 0 to pi, it means if you take cosine inverse of minus 1, the only place it could be between 0 and pi. And where is 0 and pi? Is from here to here, which means in the first or in the second quadrant. So that is why we're putting these arrows here, these quadrants here. Okay. So I explained already in general terms in the earlier video. All right. So now that is why we have 1 and 2. Then if you take cosine of both sides, we will have cosine y is just going to be what? Minus 1. But cosine is negative in which quadrant? in quadrant 2 and quadrant 3, right? So we will now take which quadrant is common. Quadrant 2 is common, right? So it means we are in quadrant 2. Now, we need to bother now about y star, right? Y star will be an angle in the first quadrant whose cosine is equals to 1. And that is just what? Y is equals to 0. Because if y is equals to 0, y equals to 0 is in the first quadrant. If you take cosine of 0, you get what? 1. Just like I said, you don't bother about the sign, whether it is negative. So now, because we are in the second quadrant, y is going to be pi minus what? Y star. This is because we are in the what? In quadrant 2. This happened in quadrant 2, right? So it means that y is going to be pi minus what? 0. So y is just going to be pi. But what is this y? Remember, y is cosine inverse of what? Of minus 1, which is equals to pi. And you can check, if you take cosine of pi, what do you get? You get minus 1. All right. Now, for the third one, which is cosine, look at this one. This one does not make sense because look at what this is saying. It's asking you to find cosine inverse of 2. So, but 2 is not in the what? In the domain of cosine inverse. Remember, this is cosine inverse. The domain of cosine inverse is from minus 1 to 1. So if I'm looking for cosine inverse of 2, this function cannot see 2 because 2 is not in the domain. So this is undefined. Since what? Since 2 is not in what? Minus 1 and 1. And you're done. So it's impossible. Okay. Now, let's do the same thing for tan functions. And just to remind us again, tan is also in the first or in the second quadrant because, in the first or in the fourth. Because remember, if you said this is y, let's call this one y to be tan inverse of what? Tan inverse of 1. So it means that what? If you take tan inverse of 1, the output will be in the range. So y will be in the range of tan inverse. But the range of tan inverse is what? Is from minus pi over 2 to pi over 2, which is just going to be the first or the what? The fourth, right? Okay, so then here, this means that tan y is what? Is just 1, right? So, but tan is positive in which quadrant? Either in the first or in the third. Now, this now will have to go with the first quadrant. So once we go with the first quadrant, then we need to find what is the famous y star. Y star will be an angle in the first quadrant whose tan is 1. And that y star is just pi over 4, right? Because tan pi over 4 is 1, okay? But because we're in the first quadrant, we're going to have y is equals to what? Y star, which is equals to pi over 4. So this simply means that what? That our y is also the same. Yeah. So y is equals to tan inverse. So let me go this way. So if you have y to be tan inverse, then we can just, so here we can have just y equals to pi over 4, right? But what is this y? This y is nothing but tan inverse of what? Of 1 equals to pi over 4. All right, so again, tan again here, and this should be b. Now for this one, let's modify this a little bit. Let's add now, instead of, let's use -3. Now, it doesn't matter. We can just call this one y is what? Tan inverse of where? -√3. This will still be in either in the first or in the what? Or in the fourth quadrant. Okay. Now, it means that tan y is going to be -√3. But tan is negative either in the second or in the fourth what? Quadrant. This is where tan is negative. So now we take the what? The common. It means which one is common here? The fourth quadrant is common. Okay. All right. So we have to find y star. So y star will be an angle in the first quadrant, right? An angle in the first quadrant whose tan will give us √3. And that is nothing but pi over 3, right? Because tan 60 is going to be √3, just like we said. Forget about this minus, right? You don't need to bother about this minus for now. So just leave it. Okay. So y star is pi over 3. Now, what is y? Because we are in the first quadrant. So y is going to be y star. So we are in which quadrant? In quadrant number 4. So y is going to be minus y star. And this is what happened in quadrant 4, right? So it means that our y is equals to minus pi over 3. And this means that y, which is tan inverse of -√3, is just the same thing as minus this. Okay, now let me just explain briefly. And another way we can do this is that with this minus, we can actually take the minus out, right? Because tan inverse is what? Is odd. So remember, just recall that tan inverse is what? Is odd. So it means that if you are asked to find tan inverse of -√3, it's the same thing as taking the minus out and doing this. All right, so thank you for watching. If you have any question, you can put it in the comment section. Just write it in the comment section. Thank you.